Today we're going to be talking about sampling. I hope that you are ready to learn about this important aspect of research reports. Our course objectives within nursing research are that we examine the components of qualitative and quantitative research designs, and sampling is one of those components. And then you're going to want to develop your critical thinking skills in the analysis of research studies as to their rigor and trustworthiness. Considering how sampling has been completed will help you determine if a study is trustworthy, or rather, to the extent that it is trustworthy. In today's class, you're going to learn to recognize the sampling strategy found in the methods component of a qualitative or quantitative research design, and you're going to become excellent at describing the strengths and limitations of different sampling strategies. These include probability, non-probability, and qualitative strategies in research. Why does today's topic matter? Well, research data that is collected and analyzed from a specific population might not answer your nursing problem. So you need to be able to recognize how the nursing problem that you're facing is similar or different from the study's sample. This will help you in recognizing if the findings from that study can actually be applied to the area in which you're having a challenge. The RN needs to critically evaluate how useful research findings are by understanding how and who was studied. So let's talk about the who, populations. Here's the big picture. A population is everyone who meets a criteria of the group that's being studied. And this always, a researcher makes decisions about that, so they choose certain characteristics. And those characteristics can be very narrow, like you could decide to study males over 40 years of age in Watauga County, and then you would sample from that set of people. Or you could try to study males over 40 years old in the entire world. And that would be a very large sample, or a very large population from which to sample. So, and these populations are not really restricted to humans. In other words, a population could even be a set of tissue samples, perhaps tumor markers from all over the world, and you could decide specific kinds of tumor cells, and then you could sample from that population of tissues. The main thing is the sample represents. So the sample is meant to be representative of that entire population. It is just not really possible to study everything within a population, and it's not really important to usually. Usually our populations are so much bigger than the amount of people we need to study that you just take a sample of it. And then if your sample can really represent the greater population, you can apply, which is also called generalize in research language, generalize the study findings to the entire population of interest. So as we said before, sampling is found in the methods section, and it helps us to draw conclusions and to generalize. So when we look at that sampling, we know that we could not generalize it to any population that had characteristics that are different from the sample. So we take the whole population, then we figure out who of that population, who do we have access to, and then within that, we draw a sample. And those are the people who actually get studied, and they're meant to represent the entire population. So we ask these questions then when we look at a sample: is do they represent the target population? Are there any biases? Sometimes people overrepresent or underrepresent certain groups within the sample, and it's important to think about. So it's not always what the author says was the sample. When you critique this and think about it, who did they leave out? Who got left out in the studies? And I believe it was around the 1990s we started to recognize that women were often left out of drug trials. Now, this wasn't necessarily because researchers weren't concerned about women's response to medications, but instead women were left out because of the risk that researchers didn't want to hurt an unborn child. And so women were often left out of drug trials who were in childbearing years for those reasons. And then there can be sampling error. That's when there's a difference between the population and the sampling values. And this can occur for many different reasons. Well, how do we choose a sampling strategy? Often they're very real world, and this is a world picture, reasons. Sometimes a strategy is more economic than another, and we might not have research funding to support a bigger sampling. So it might be more convenient or efficient for us to sample a certain way, or the issue that we are studying is narrow enough or of less significance, so it's unnecessary to sample from the entire population. So we're going to talk now about specific probability sampling. And the next several slides will talk about how we get a subset of the population. A very key term to this is random selection. Random selection means that a person in the subset of the population has an equal opportunity to be chosen to be in the study. A simple random sample, we define first who the population is, and then we decide what kinds of characteristics of people in that population we want to select, and that's called a sampling frame. And we decide to represent our population with this sample by, for example, assigning numbers to everyone who fits that defined sample frame that we designed, and then we will auto-generate random selection of people who meet those characteristics. In this way, we get a fairly representative sample from the populations. It can take a lot of work, and you need to have a full list of everyone who's eligible prior to your enrollment of them in the study. So first you collect all the people who meet the eligibility requirements for the study, and then you go ahead and select randomly the sample out of that list. And some of those folks will receive likely an intervention, and others may serve as a control. Another method of selecting them from simple random sample is using a table. In this case, again, you go ahead and you assign everyone who comes into the study a number, and then you use a table such as this. And when you have these numbers, you would take number 2, subject number 31, subject number 10, subject number 88. And so you use this table of random numbers to select the people who will participate in the sample. A third type of probability sample is called a stratified random sample. And in this case, you have your list of potential participants, and then you go ahead and put them in groups by what's called a strata. Strata is simply a characteristic that you want to emphasize or control for in your study. So if you think within this group, there might be major differences based on a characteristic, you might select that out as a strata and sample within each of those characteristics. In this example, race was used as the strata, and and people who were in the study or potentially in the study were collected and sorted into basically these three groups. And then they were randomly sampled from the subset of this larger population. And in this way, you can basically take equal numbers from each strata if you want. So who knows what the percentage of Caucasians were on this list of clients, but you could go ahead and take 10 people here, 10 and 10, but that might be disproportionate, see, because 10, 10, and 10 might be different than your population. Or you could take the same percentages, such as in Watauga County, about 10% of the county are African American, about 20% are Hispanic, and then about 70% are Caucasian. So then when you drew your sample down here, you could do so in a similar proportion. So you would draw then 7 Caucasians, you would draw 1 African American, and 2 Hispanics for every 10 people that you drew from the sample. And that would be considered proportionate. So in this case, your percentages would match your population. So this is very labor intensive to do and can take a long time to achieve your sample, but this is another type of probability sample. Remember, probability samples are necessary for what are called causal studies, studies where we're trying to understand cause and effect. Then we have cluster sampling. This is where you random sample units and then you random sample them again and then again. So you may not have a listing of all the elements that you need, but this is very practical as people come into the study. So you might take here's an example of a cluster population sampling. And then we have systematic sampling, and that's where you select, in this case, every third case. You divide them up by sample size, you divide the population up, and then you have to put them all in a random order, and you just basically take every third, and that would be considered systematic. Now, it doesn't have to be every third, it could be every fourth, every other, but it's systematically done after placing people in a population in random order, and that's your systematic sampling. All right, now we're going to talk about our second form of sampling for today's lecture, and that is non-probability sampling. Non-probability sampling is not random, and as such, you cannot, with non-probability sampling, it's very difficult to make a case for cause and effect. So this kind of study, most often, is a relationship between characteristics, which is called a correlation. Because there's an increased risk for bias, we cannot easily generalize this to other groups. But this type of sampling is more convenient and economical, and sometimes there's no other option. So the first type of sampling is called a convenience sample. In this case, you use whoever is most available to the researcher, and you invite those folks to participate. They may still have specific characteristics that you want people to meet, but they are not randomly selected. Instead, there's just a convenience. If you come in the door and you want to participate in the study, you meet the requirements, you're in. So this is the weakest form for causality studies. And then we have quota sampling. It's similar to convenience, but you again identify by strata. So you take people conveniently, but once say as in the other example, once you have your 7 Caucasian people, you stop enrolling in that study and you'll start only enrolling Hispanic and African American folks into your study. So the idea is you have this diverse representation that's equivalent to the population. And so that is quota sampling, but it is different from the probability sampling where we had everybody and then drew them randomly out from those strata. So in here, we just take the first 10 that arrive, the first 11 here, the first 7 there, and that's how those two kinds of quota sampling are different. So when you're in the non-probability sample, the other option you can have is selection by a purpose. So you can handpick people that give that most meet the cause or the purpose of your study. You might be looking for a lot of variety, or you might, in contrast, look for somebody who's the most typical. So you exclude people from your study if they don't have a typical set of features, and otherwise you would avoid them. And this is also very helpful when we develop instruments, which are called, an instrument in this case is a research tool for measuring research effects. And so we often will take a tool that's been newly developed and take it to some experts and ask them for their evaluation of that. And so they were very purposely selected because of their expertise, and they provide information on the content analysis of that instrument. However, as you can see, there'd be a lot of bias in this kind of purposive sampling. In quantitative studies, when we look at sample, the largest possible sample is usually the best. And the main issue of the sample size is that it represents the population, and it's very important in quantitative studies that the sample is all very similar. That gives the most amount of control. If the people in the sample are all very different, it's difficult, again, to draw causality, and it may take a very large sample size to be able to see the effect size because of all the other confounding variables in the study. So remember, quantitative samples need to be homogeneous, and that increases their precision. Now, power analysis is a procedure that can help you tell how many people you should enroll in your study if you want to see a specific effect size. So the key thing I want you to know is when you read a study, if there's a statistical test done, the author should report on their power analysis and what number of people they needed to enroll in their study in order to see a significant effect. And a significant effect means an effect that wasn't just by chance, but was actually because of the intervention. All right, here it is, number 3, the qualitative sampling. So in qualitative sampling, researchers are not as concerned with if their sample can be generalized to the general population. Instead, they are exploring a phenomenon more deeply, and so they're looking for people who can give the most detailed information about a specific phenomenon. So often, the sample is very small and it's not random. So the important thing is the richness of the data. Here's some types of qualitative sampling. Key informants. These are people that know the most about a particular issue because that they are dealing with that issue day in and day out. It can start with a convenient sample who's available, who might know it. But often then from that convenience sample, you ask those people who they know that might also have information on this. So there's a networking that's done. And the study questions can evolve and can be done theoretically or purposefully. And so this is quite different from the quantitative sample, which is very concerned about control, because these samples are more information more information focused. They're more, they value more the information they can obtain from people participating in the study than the control of the study itself. So we might sometimes look for maximum variation in the sample, and that will give the broadest amount of information. So a qualitative study that isn't looking to have a lot of exclusion criteria, they really just want anyone who is experienced in the specific phenomenon, and then they will do the research from that. So they will also look for extreme or very, we use the term deviant, but it really means that somebody, if you think of the bell-shaped curve, we really want to study the people who are on the two ends of that bell-shaped curve. Whereas the quantitative study with the N, quantitative studies are interested more in means and variation around the mean and looking at the average person of a particular population. Qualitative sampling is more interested in the tails of that bell-shaped curve. Or sometimes they will look for a typical case, but those are the kinds of things that qualitative sampling involves. So in the sample size, there's really no firm rule about the number of people. The important thing is that the sample just aligns with the purpose of the research question. And this is a term that you will see when you read, and that is data saturation. So you want people to be sampled to the point where no new information is obtained. So when no new information is obtained, and for me, I had planned to sample 15 people, and it took about till I got to 10 that I was hearing the same kinds of stories, but I sampled beyond that. I think I did another 3, and there was no more information. So at that point, you make a determination that you have data saturation, and you can close your study to enrollment. So what are we always looking for when we read our research report? We're asking questions, is the sample adequately described? One thing you should know is samples are usually displayed in a table form, so you won't always see it in the write-up. So if you're just reading the study and looking at the section labeled methods, and they always start off with the sample or the participants, if there's not much detail there, see if they are not referring to a table, and that can be found there for you. And then you wonder, did they make good decisions? So if you're a quantitative study, you're wondering, did they make a decision that really represents the population? And if it's a qualitative study, you're wondering, did they really get an adequate amount of information from their sample? And was the sample appropriate? Who was left out? Who else could have been asked the questions? So when you are critiquing the sampling of a qualitative study, you should not say the sample size was small. That is just known. Yes, we know a qualitative sample has a small sample size. That's not what you critique with a qualitative study. Instead, you critique it on adequate and appropriateness. A quantitative study, however, could be critiqued on the size of the number of observations made. So just realize that size matters in a quantitative study, but quality matters in a qualitative study. So today you learned about sampling, and there were 3 forms: quantitative probability sampling, quantitative non-probability sampling, qualitative with an L sampling, and these different types within them. So there was simple, stratified, systematic, and cluster sampling, or all the probability. And remember, probability sampling means that we can tell cause and effect. And then for non-probability sampling, we have convenience, quota, consecutive, and purposive. And these samplings are for causality, or not causality. These samples are for a relationship. So that's called a correlation. So non-probability, think correlation or relationship sampling. Qualitative sampling has to do with the richness of the data, the detail, the description, the insight, the depth of knowledge. And so those sampling strategies involve key informant, convenience, volunteer, snowballing, theoretical, and purposive. So I hope you enjoyed looking at these different sampling options and techniques, so that when you see these words, you will immediately have some knowledge of the decisions that the researchers made, and if your needs will be met by a specific type of study, or if you should keep looking for other evidence to help you understand all kinds of nursing research problems. Thanks for listening to the presentation, and I look forward to seeing you in class. Have a great evening.